Okay, back again. This is part 4 of service calculations. And as you can see back here, I've kind of set things up so that we can go ahead and we can work through the math on a problem. We can fill in all our VAs for the different places here, do our total, and then size our service conductors. If you have not watched the other parts, some of this or a lot of this probably won't make sense. So make sure you go ahead and pause this and go back and watch those first. Okay? Before we get started though, we're going to go ahead and I'm going to start off with a joke. So, there's a couple that have been married for 50 years. And the man says to the woman, "You know, honey, 50 years ago, we slept on a crappy bed. We lived in a crappy house. We drove a crappy car. And we watched a 10-inch black and white TV. But I got to sleep by a beautiful 23-year-old woman. Now, 50 years later, I worked very hard, and we have a nice house, we have a great bed, we drive a great car, and we have an 80-inch flat screen TV. But I have to sleep by an old 73-year-old woman. Seems like you're not keeping up on your end of the bargain." So the wife looks at him and says, "You know, honey, why don't you go out and find yourself a beautiful 23-year-old woman? And I will make sure you are sleeping on a crappy bed, living in a crappy house, driving a crappy car, and watching a 10-inch black and white TV." Got him. Okay, that was your joke. That was your joke. Okay, so let's get to this here. So we started off, and at the first video that you watched, part 1, we talked about our square feet and our small appliance and laundry circuit, right? So it said we take for a dwelling unit, and this is what we're figuring. It says we take our square feet and we times it by 3 VAs per square feet, right? So we get 6,900 VAs, right? Then it also said we can take our small appliance circuits here, and the small appliance and our laundry circuits. Now, when we talked about minimum is 2 small appliances. It could be 3, it could be 4, depending on what the house needs. It could be more, right? Whatever the house needs. If you got a really big kitchen, you might need 3 in your kitchen, right? And so, but it's how many ever you have, that's what you're working with. Same with laundry. Minimum is 1, but if you would have, let's say, 2 laundry rooms, one in the basement, one on the main floor, right? If somebody's using your basement, then you would have 2 laundry branch circuits. And so you just need to make sure you know how many you're going to have, right? And so in this case, we have 1 and 2. It says that we take that total number of those 2 and we times that by 1,500 VAs each, right? So we take 1,500 VAs times 1, 2 equals 3. 1 plus 2 equals 3. We take it times our 3 circuits, and we get wrong spot. We have 4,500 VAs, right? And the code also said that we can add this VAs for the small appliance laundry circuit in with our general lighting. So put this up here. And we come up with 11,400 VAs. Okay? Now, code says that we have to take the first 3,000 VAs and take that at 100%, right? And I'm going to get you the code numbers here. So we're looking at table 220.42 under dwelling units. It says the first 3,000 is at 100%. So we want to take that out before we do our duration factors. So subtract 3,000 So we get 8,400, right? Check my math. Okay. So now our remainder here, if we look at our table 228.42, it says from 3,001 to 120,000, it's at 35%. So we take that times 0.35. Okay? And we get 2,940. Okay? That's our reduce of the 35%. But we have to then bring back in that 3,000 at 100% that we had taken out. So we add that up, and we get 5,940 VAs. Okay, this is our general lighting load over here. So I'm gonna move this over here. I'm trying to write neatly so you can read it, hopefully. I moved the camera up, hopefully you can still see. Okay, so our small appliance and our general lighting basically is done, right? So we're done down to here. Next up is our dryer. And according to our code, the dryer, if you look at 220.54, it says our minimum is 5,000. But it says if our nameplate is higher, and right now I said our nameplate is 6,100, we use that number, right? And since this is higher, our dryer is going to be 6,100. And that just gets moved straight over. Okay, so now we're done down here. So now we have a range. And we were saying these are all going to be on one circuit. This one kitchen. They have a range, which is your one appliance that has your burners and your oven on it, right? The CMCU, counter-mounted cooking unit, and this wall-mounted oven, they're also on that same circuit, right? This person just really likes to cook, okay? So we're going to say those are all on the same circuit. So now we need to do the math for that. And I think I'm going to do the math over here for it, just for room's sake. So what we need to do then, since we're on the same circuit, we need to add them up. Okay, so we have a total of 20,000 VAs for all three parts of our range, right? Now, since when they're all on the same circuit, we have to look at work with table 220.55 and the notes below it, okay, like I told you in the other video. But since they're on the same circuit, it counts as one appliance. So, if you go to one appliance on table 220.55 and you follow it all the way across, because we're well above those ratings, it says that we have to factor in 8,000 watts, right? Or 8 kilowatts for up to 12,000 rating, right? We're over 12,000 rating, right? So, and this is what I call that 8 there, the base 8, right? Because up to 12,000 is going to be 8. If we are at 11,000 total, it would be 8. 10,000 total, 8. Okay? Up till that 12,000. Above 12,000, that's when we have to adjust. So then what we need to do is take that 12,000 out. Okay? Because we already are equating, or we already are taking care of that with the base 8, the 8,000 VAs. And we come up with 8,000 left over. Okay? So, it says in the code that for every, if you look at the notes, it says for every 1,000 VAs or major fraction thereof that were over 12, we have to add 5%. So, if it makes it easier to find how many 1,000s over you are, just go ahead and divide this by 1,000. And we get 8. Right? So we are 8 1,000s over. So we have to do 5% for each 1,000. So 8 times 5%. Okay? That equals 40%. Right? So what that is saying that is we have to take our base 8, since we're using one appliance, and add 40% to it. Okay, so we'll write our 8,000. And remember, this 8,000 is for the first 12. And then we're going to take that times, we're going to add a 1 in front of it because we're going up 0.40 for 40%. Okay, does that make sense? 8,000 is our base 8 found on table 220.55. The extra 8 that we had above the 12,000 times 5 is 40%. So that's what we're multiplying by 1.4 to go up 40%. Okay? Do the math on that, and we get 11,200. Okay? That is our total that we need for our range for the calculation. So this number will come up here. Okay. Now, if we finish this here, so the next thing is our furnace at 50,000 VA. Now, looking in our code, and also, of course, watching the other videos, you will know that it talked about non-coincidental loads, right? And so, if we look at, give me one second, 220.60, it says, and I'll say it again, where it is unlikely that 2 or more non-coincidental loads will be will be in use simultaneously. It shall be permissible to use only the largest loads that will be used at one time for calculating the total load of the feeder or service. Okay, so what that means is, since our furnace and our AC unit or non-coincidental loads are not going to be on at the same time, we don't have to do both. We can just do the larger of the two, right? Your furnace is pretty much always going to be larger. And again, I told you in that other video that, let's say we have a heat pump in our AC unit, we would have to add the heat pump in for our total furnace load because it can be running at the same time. We're going to figure the heat pump is already in here, and that's why it's 15,000 VAs. Okay? But it doesn't say any sort of reduction, so we have to use this total number in our calculation. So we just transfer that over. Okay, so we're done down to here. And you can see here we only got 2 more things to fill in. First is going to be our facet in place, right? So we said the water here, it's already on VAs, so we're just going to transfer this over like this. Okay? Our water pump, we know when we talked about this in the last video, these two here, water pump, water heater, are all 240 volts. We need to make sure we know our voltage. So we have to multiply, to get this to VAs, we have to take your 11 amps times 240 volts, and we get 2640. Okay? The dishwasher and the garbage disposal, we know are both 120 volt loads, so we got to multiply both of those by 120. Okay, and we multiply 7 amps times 120, we get 840. Oops. And we multiply 8 times 120, and we get 960. Okay, so then we need to add all these up. So when we total these up, we get 6,540. Okay. Now, since we have 4 or more, according to article, let me find it here quick, 220.53 appliance load, it says that it shall be permissible to apply a demand factor of 75% to the nameplate rating load of 4 or more appliances. Okay. It also says a quarter inch or larger, or a quarter horse or larger, and 500 watts or larger, which these are. Okay. And so, since we have 4 or more, we can apply 75% demand factor. If we had, let's say we didn't have a garbage disposal for some reason, we only had 3, then whatever it added up to, that's what we would use. But since we have 4 or more, we can do that 75%. So we take our 6540 times 0.75, and we get 4,905. Okay. That number, 4,905, is what we're going to plug in over here. Okay. Okay. So then we only have largest motor load left, right? And that's going to be based out of our fasten in place appliances. Now, we talked on the last video about the water heater. Even if that would be larger, we wouldn't use it, right? Because it's not a motor load. It doesn't have a motor. So even if that was 3,000, we wouldn't use it. So we go to our next largest motor load, which is our water pump, 2,640, right? And 430.24 tells us we have to use 125% of the largest motor load, but we've already used the 100%. So now we just need the extra 25. So we take our 2640 times 0.25, okay, equals 660, right? And that takes care of now our largest motor load. 660 just gets transferred straight across over here now. Okay, so now we filled in all of our spots for our VA values. Now we need to total them. So if we total, we add all these up, we get 43,805 VA. Okay? So, now how do we size our conductors off of this? Well, we know we can't do in VA because conductors are sized off of current, right? So, if we go and divide this by our voltage, that'll tell us our current. Our voltage is 240 in residential setting. So, we're going to divide it by 240 volts. And that gives us 182.52 amps. Okay. Now, we have our amperage for our ungrounded conductors, and we can size then our conductors. So, let's go ahead and let's turn to 310, table 310.16. We turn to table 310.16. Since we are using, normally we use our 60° C column to size our branch circuit conductors. Because the terminals usually, like on our receptacles and stuff, are at that 60° C rating. Plus the code tells us that on our normal branch circuits. But since we are connecting to a panel and to, let's say, our meter box or something, then those are actually going to be rated a little higher, usually at 75° C. So we will actually use a 75° C column to size our service conductors. So if we follow 75° C, we're looking for the next one bigger than 182. So if we follow that down, next one bigger than 182 is 200. And that 200, if we follow that across, and this is under the copper side on the left, we find out that we need 3/0 conductors. Okay, so this whole set of calculations was to find out that we needed 3/0 conductors. And these are ungrounded. Right? In the next video, then we'll figure out how we go from here and we get our grounded conductors. Okay, the neutral. Now 3/0, that's not where we stop. Because, yes, this will work, obviously, but the code allows us, since we're in a single family dwelling unit, and we're feeding one main panel, it allows us to actually derate further. Okay, so if you turn to 310.12a. Okay, that's single phase dwelling services and feeders. And then A is services. It says, let me read it to you, for a service rated at 100 amps through 400 amps, the service conductor supplying the entire load associated with a one family dwelling, so one panel, or the service conductor supplying the entire load associated with an individual dwelling unit in a two family or multifamily dwelling, shall be permitted to have an ampacity not less than 83% of the service rating. Okay, so what that is saying is, in this case here, 182, most likely we're going to use a 200 amp panel, 200 amp service, right? And so we can actually take that down to 83% of that service rating to size our conductors. Okay, so if you take 200 amps for our service times 0.83, let me grab my calculator. So 200 times 0.83 gives us 166 amps, right? So we can actually size our conductors for that 200 amp service down to 166 amps. Now, I'm going to turn to 310, table 310.15, or 16, excuse me, and 166, the next one larger is 175 amps, follow that across, and it says 2/0. So we can actually size our conductors for 2/0. Now, one of the nice things, one of the changes is in this code book for this year is they added in table 310.2, right? Before, all this information was just in the paragraph. You had to do your own math all the time. But if we look at table 310.12, it says single phase dwelling services and feeders. On the left side, it says your feeder or your service or feeder rating, 100 amp through 400 amps, right? And then it tells you your copper conductor size or your aluminum conductor size. So we said we're going to have a 200 amp service. If you follow it down to your 200 amp service, go to the right under copper, right there it tells you 2/0. Wouldn't have technically had to do the math, right? And so that's what's one thing that's nice, like I said, about this code is they gave you the table back, because the table was in there and they took it back out. But they brought the table back in, so it's just really easy. You find your service size, find your conductor size. Okay, but we have to do this here because let's say we wanted to do a 200 amp service, right? And we did all of our math, and then it came up with like 215. Well, we obviously can't do a 200 amp service, right? So then we would have to go up to 225. Okay, does that make sense? And so, and then a 225 would be a 3/0 service. The 3/0 service conductors instead of 2. Okay? So I hope this all made sense. Go ahead, and if there's any parts in there that you missed or didn't understand, just go ahead and back up and rewatch it. I hope I went slow enough so that you understood everything. So if there's any other questions or comments, go ahead and leave them in the comment section below. And like I said, our next video will be over the we'll be sizing the neutral side, the grounded conductors, instead of the ungrounded side. Okay, and that then will be the end of our service calculations. We'll have both sides, or both conductors sized. Okay, all right. We'll see you on the next one.